All right, so the inflammatory system can be kicked into gear either by like a mechanical injury or some sort of pathogen invaders. The immune system can be activated by the innate immune response through pathogen associated molecular patterns, and these patterns are kind of part of the innate immune system, so our body already kind of has them even from birth. And these PAMPs bind to pattern recognition receptors, and that kind of sparks the release of the pro-inflammatory cytokines. These are known kind of, for example, like interleukin 1 or interferon alpha. And most importantly, the cytokines lead to swelling and redness, and sometimes that sort of that heat pain you feel through the inflammation. Um, that sort of thing is kind of the hallmark of an inflammatory response. You have the pain, the redness, and that's because there's an increase in the blood vessel permeability, which causes more blood to flow into that wounded area. So in order for the inflammation to really work, there has to be kind of these first responder cells, and these are like cells that can eat other cells, so phagocytic cells. And when they eat the invading microbes, they're then able to kind of become antigen presenting cells for the body's T cells. And then that causes the synthesis of cytokines, which will then activate the B lymphocytes. And then the entire inflammatory response persists through a process that kind of involves chemotoxins, and that causes those phagocytic cells to converge into the damaged tissue that's kind of under attack. And that's kind of in an effort to activate the acute phase proteins. And these proteins are really important because they activate like the complement system, which basically just kind of leads to an increased destruction of the invading microbes through like enhanced cell rupture and cell eating. So this acute inflammation is really a key step of the healing process overall. But there is such thing as chronic inflammation, and that might kind of be something you especially recognize because, for example, some of that is arthritis, and the inflammatory response is shut down at the end when everything's said and done, and your body's like, okay, we no longer need this. It's ended by interferon beta, which that just kind of promotes the final number of the fibroblasts and the matrix proteins, which then leads to that sped up tissue repair. So you can get it back to being healthy and happy, and you can go back to living life as you know it before the immune response happened.